Let us discuss the quadratic formula and the discriminant. In our previous lesson, we discussed about the quadratic formula, wherein this formula, it gives a solution to any quadratic. So in any quadratic equation, ax squared plus bx plus c is equal to 0. Using the formula, x is equal to negative b plus minus square root of b squared minus 4ac over 2a. From the quadratic formula, we have the expression b squared minus 4ac, and this is called as the discriminant of the equation. This can determine the number and type of solutions to a quadratic equation. So we have here the number of solutions. Using the discriminant b squared minus 4ac, if b squared minus 4ac is greater than 0, there are two real solutions. Number 2, if b squared minus 4ac is equal to 0, there is one real solution. And if b squared minus 4ac is less than 0, there are two imaginary solutions. Let us try to find the discriminant of x squared minus 6x plus 9 is equal to 0. Let's identify our a, b, and c. So our a here is 1, b is negative 6, and c is positive 9. So using the expression b squared minus 4ac, we will substitute now the value given to a, b, and c. So we call this one as our discriminant, and we may denote it as capital D as discriminant. So D is equal now to our b, which is negative 6, is negative 6 squared minus 4 times your a, which is 1, and times c, which is positive 9. So it's equal to our d, negative 6 squared is positive 36, minus 4 times 1 is 4, times 9 is 36. So 36 minus 36, therefore our d is 0. So if our b squared minus 4ac is equal to 0, therefore there is one real solution. Let us check our equation x squared minus 6x plus 9 is equal to 0, which has two equal real roots. Let us check it by factoring. So we have to use the x box. So we have 9 here as a product, and the sum, which is negative 6. So factor out 9 that it will give us negative 6 as its sum. So we have negative 3 and negative 3. Negative 3 times negative 3 is positive 9, and negative 3 plus negative 3 is equal to negative 6. So therefore, our roots are x is equal to 3 and x is equal to 3. Let's proceed to our case number 2. We have b squared minus 4ac is equal to 0. There is one real solution. Let's try to solve x squared minus 8x plus 15 is equal to 0. So first, let's identify our a, b, and our c. So from the equation, our a is equal to 1, b is equal to negative 8, and c is equal to positive 15. So our discriminant, which is b squared minus 4ac, we have to substitute the given value of A, B, and C. So, we denote again as capital D is equal to your B squared, which is negative 8 squared minus 4 times your A, which is 1, and times C, which is 15. So, simplify the equation. So, D is equal to negative 8 squared is equal to positive 64 minus 4 times 1 is 4 times 15 is 60. So, D is equal to 64 minus 60 is equal to 4. Since b squared minus 4ac is less than 0, then x squared minus 8x plus 15 is equal to 0. So therefore, what we obtain as our discriminant, which is equal to 4, so the equation has two real roots. By checking that x squared minus 8x plus 15 is equal to 0, which has two unequal real roots, let us check it by factoring. So we have to factor our original equation, x squared minus 8x plus 15. So the factor of it is, we have x minus 3 and x minus 5 is equal to 0. So therefore, our x here, using the 0 property, so we have x minus 3 is equal to 0 and x minus 5 is equal to 0. By transposition, so we have x is equal to positive 3 and our x2 is equal to positive 5. In the third case of determining the nature of the root of the quadratic equation, we have b squared minus 4ac less than 0, which has two imaginary solutions. Illustrating the third case, we have an example, x squared minus 3x plus 4 is equal to 0. So, identify our a, b, c. So from the equation, our a is 1, b is negative 3, and c is positive 4. So, getting the discriminant, so we have d is equal to b squared minus 4ac. So, our d is equal to b squared is, we have negative 3, get the square, minus 4 times your a, which is 1, and times c, which is positive 4. So our discriminant is equal to negative 3 squared will become positive 9 minus 4 times 1 is 4 times 4 is negative 16. So we have d, which is 9 minus 16 is equal to negative 7. Since our b squared minus 4ac is less than 0, therefore, the discriminant that we obtain, which is negative 7, has two imaginary solutions. Let us now verify our x squared minus 3x plus 4 is equal to 0, which has two imaginary solutions. So, first, we have to find the value of our a, b, and c. Your a here is 1, b is negative 3, and c is positive 4. In verifying, we will use the quadratic formula. Negative b plus minus square root of b squared minus 4ac over 2a. Let us now substitute the given value of a, b, c to the quadratic formula. So your x here is negative times your b, which is negative 3 plus minus square root of b squared, which is negative 3 squared, minus 4 times your a, which is 1, times your c, which is positive 4, over 2 times your a. So x is equal to negative times negative 3 will become positive 3 plus minus square root of negative 3 squared is positive 9 minus 4 times 1 is 4 times 4 is negative 16 over 2. So x is equal to 3 plus minus 9 minus 16 is square root of negative 7 over 2. As you can see, we have a negative number. So there is no negative or square root of a negative number. So we have to simplify square root of negative 7. So square root of negative 7 is equal to negative 7 times the square root of negative 1. So we have square root of 7 and square root of negative 1 is I. So our x1 then is equal to 3 plus square root of 7i over 2, and our x2 is equal to 3 minus square root of 7i over 2. So that are the roots which has two imaginary solutions.